Hey, welcome to Algebra 1 CST release question number 7. It says, what is the solution for this equation? You've got 2x minus 3 equals 5. So consider this before we go through this. I want us to be able to do a problem like this without just plugging in numbers. Yeah, that's something you could fall back on if you needed to, but you're not always going to be taking a multiple choice test to do a question like this. And so let's see how we could figure this out without using the choices here. And so consider this, that the absolute value of 5, well, that clearly equals 5, but also the absolute value of negative 5 is going to equal 5. So think about that as we solve this problem. I want you to think of this inside the absolute value as kind of being in parentheses. Think of this as an entire entity or an entire chunk, entire thing all together. So this whole thing all together, whatever 2x minus 3 is, in the end, could either equal 5 right here or negative 5, because the absolute value of both of those things ends up being positive 5 in the end. So think of this all together as being either 5 or negative 5. Thinking of it like that, so as 5 or negative 5, brings us to this point where we can say we've got basically two equations to solve for here. We can either say that 2x minus 3 altogether could equal 5, or 2x minus 3 altogether could equal negative 5, because after you take the absolute value of both of those numbers, 5 or negative 5, you end up getting 5 as your answer. And so right here, now we have two pretty straightforward basic algebra 1 type problems here. We're solving for x. So add 3 to both sides, keep that equation balanced by adding or subtracting the same thing on both sides. Just like a scale in science class, you'd add something on one side, you'd add weights, the equivalent weight on the other side to keep it balanced. So equations just like that. Blah. So x equals, what's 8 divided by 2? Now we're dividing both sides by the same thing. We've got x equals 4. This is one possible answer. So it looks like that's eliminated these two, because those two don't even have 4 as an answer. But let's see between those other two choices which one it is. And so we have 2x. We add 3 to both sides. That'll cancel the subtracting 3 right there. You'll have negative 2 right here. Divide by 2 and you get your answer. The 2's will cancel here and here. You'll get that reduced down to negative 1. So your answer here looks like choice C is the correct choice. I'm just going to do, on this one at least, I'm not going to do this for all of them, but I'm going to do a quick check to show you that that actually worked out. So let's check both of these equations and see that 4 is a valid solution and that negative 1 is also a valid solution. So let's see if this works out. 2 times 4 minus 1, does that in fact equal 5? I'm going to put a question mark above the equal sign because I don't know yet. And I put a 1. I was getting usually confused there. I'm like, that doesn't look right. It's because there's a 3. So be careful, Mr. Wagner. Okay, I will be. All right. So I've got 8 minus 3. Absolute value of that, does that equal 5? Well, 8 minus 3 is 5. And so 5, absolute value of 5 equals 5. That checks out. I can do the same sort of thing with negative 1 to check that and see if that also works. So I'll put a question mark above that first. This would be negative 2 minus 3. What's negative 2 minus 3? That's negative 5. And so here was the positive one like we thought it would be. We thought it would be 5. Here was the negative one. It should be negative 5. The absolute value of negative 5 does in fact equal positive 5. So both sides, both solutions, check. With equations, with algebra, always a good idea to check your answers in the end. Plug them back in and see if the answers are actually valid solutions to the equation, the original equation. I see no reason to wonder if you got the right answer when you can just easily check and see if you did get it right. All that aside though, number 7 looks like was choice C.